Good morning, everyone, and thank you so much for joining us for today's webinar, Mass Timber Kit of Parts, Poplar Road Junior Public School. My name is Claire Hepburn, and I am the Deputy Registrar at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin today's webinar, I would just like to share some housekeeping points with you. Do know that we are recording this webinar to make sure that for quality and educational purposes. To have a stable internet connection, we have muted all participant microphones and disabled your video feeds, but we do encourage you to engage through our Q&A window. So you'll see at the bottom of your screen, there's a Q&A button. At any point during the presentation, please do submit your questions there, and we will wait till the designated question and answer period towards the end of the presentation to answer your questions. Also note that our chat function is reactivated as well. For those of you who are seeking continuing education learning hours, do know that your attendance is crucial and you will need a minimum of 80% attendance to be accredited those hours to your transcript. Allow us a week or so to upload and report those hours. The presenters today do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during a webinar. We provide closed captioning services available in multiple languages to accommodate the needs of our diverse audience. Now I am excited to introduce today's speakers. Please welcome Carol Cochrane and Will Klassen. Over to you.
Thank you. Thank you to the OAA team for having us today, and thank you to everyone who has joined us to be a part of this webinar. We're excited to be here to talk to you about, this will be the first Mass Timber School for the TDSB, and to talk through strategies for using mass timber and kit of parts type strategies that we've developed for this project.
My name is Will Klassen. I'm an associate here at Moriyama Teshima. I've been here for the better part of, I think, 19 years now, and I've had the pleasure of working on a bunch of school projects with the office, as well as a couple of our mass timber projects. Yeah, I'm also really happy to be here.
I should probably introduce myself too. Carol Cochrane. Thanks, Will. Carol Cochrane. I am an architect here at Moriyama Teshima Architects. I've only been here for a couple of years, but I've been immersed in kind of the mass timber side of things. And I was PM for this project, so I've been kind of following it through from day one, and hopefully handing it off to construction soon. So just to go through a quick agenda of what we'll be going through today, we'll start with a general introduction to mass timber. I think some of you may know more than others, but it's always good to make sure that those of you who may not know as much can get that information. And then we'll get into kit of parts and what that means and how we work towards that and work with kits of parts. And then we can go through the Poplar Road design solution that we've come up with. And finally, just a bit at the end, a bit of the nitty-gritty on the mass timber procurement strategies that becomes an important piece when we're doing these kinds of projects. So I'll pass it to you, Will, for you to start on the introduction to mass timber.
Yeah, thanks, Carol. Yeah, I just wanted to echo Carol's sentiment at the beginning, thanking the OAA for giving us the opportunity to share this with you guys. It's a project that we're really excited about, and hopefully we can keep your attention for longer than the required 80% of of the session. So yeah, like Carol mentioned, we're just going to do a very high level, quick overview of mass timber, just so that you understand what we're talking about and how that sets up the kit that we eventually developed for this school, what the different products we're going to be using, and the different structural configurations that we explored before getting to our final solution. So apologies if you know some of this stuff already. But it's a nice kind of a refresher anyway to understand what all the different pieces are doing in this system. So just very basic, what is mass timber? Mass timber is essentially large engineered wood products. Uh, Whereas previously, historically, mass timber buildings, like the one that our office is in, have these big columns that are made out of single trees, large timber members. We've moved more to laminated products, glue laminated and CLT, to make up our larger members to be able to manage the forest a little bit more sustainably rather than taking down that old growth. Um, Mass timber is also able to now take more loads, span farther, and has an inherent fire resistance rating, which allows us to apply it to many more building typologies. Um, if you want to go to the next one, Carol. All right, so just we're going to talk about just the three basic mass timber products. There are a lot more than that when you get into laminated strand lumber and mass plywood, but for our purposes, we're just going to stick to three. The first one just being straight up glulam beams and columns. So the key factor here is that all of your wood members are running in the same direction. This isn't really new technology, but uh, at this point, we're able to build them much larger. In some of our projects, we've gotten up to 4 feet wide in terms of one glulam column. But yeah, it's the conjunction of several members working together as one, and that would be your glulam. Next. And then this is the real kind of game changer is cross laminated timber. So this kind of came into the scene in the 90s in Europe and has since made its way into North America and Canada. And the differentiating factor here is essentially what's described in the name as cross laminated timber. So this is where every wood member, every lam is oriented perpendicular to the one that it sits on top of. And what this achieves is essentially a two-way slab, where a lot of our old post and beam buildings that you find warehouse buildings are made with either nail laminated timber or maybe even dowel laminated timber. Those are one-way slabs, so you're just spanning beam to beam. A CLT slab has that two-way action, which frees it up a lot structurally, and then we can go quite thick with these. So minimum, you have to do three plies, and both the top and bottom lam are oriented in the same direction. And then as you add more and more layers, you're going up in increments of two so that you maintain that same symmetry on top to bottom. So 3, 5, 7, up to 9 ply members. Next. And then, as I mentioned before, their nail laminated timber and dowel laminated timber are still quite ubiquitous. There are a lot more suppliers that can make nail laminated timber and dowel laminated timber across the country than there are that can produce CLT. There are definitely advantages to NLT and DLT. They're generally cheaper, and if you can see in this product that I've got up on the screen, this is a DLT from Structure Craft out in BC. And they've taken it one step further and routed out every member to allow for that void where they can fill it with acoustic insulation, which is fantastic given that CLT slab is just going to bounce your sound all over the place. So that's one of the drawbacks of CLT, and is something that that NLT and DLT have this ability to include. The main drawback with these are that they are still that one-way slab, so you're only really spanning beam to beam, rather than having that two-way action of the CLT. Next. So given those products and those members that we're going to be using, I was going to go over a few different structural configurations that that we've used and that are fairly common in the mass timber space to achieve the kind of spans that that we often look for in our projects. The first just being a very straightforward post and beam with a deep beam configuration spanning in one direction. So the image on the screen is our project at McMaster University. This is their life science building. It also has the great greenhouse attached to it. But this is a fairly straightforward configuration where you can see those wood columns along the curtain wall just marching along, and then the beam spanning just straight across that space. The advantage is these long spans that you can get. The disadvantages with this configuration are that your beams can get quite deep. So if you have a tall building, then that can increase your floor to floor pretty significantly as you move up. And you can only really run your services if you're running them in the ceiling in one direction, unless you're going to be penetrating each one of those beams. So as you can see, there's some ductwork in between those glue lamps, but they're really only running in one direction towards the windows. If you have to cross under it, then again, you're kind of sacrificing your ceiling height, and it just takes a lot of coordination. That can be done. It almost has to be done on every project with, you can see with the sprinkler line here in the foreground. But it does present a coordination piece and some additional height. Next. If we start to add girders to our beams, it gives us the freedom of orienting our CLT slabs in other directions, that they don't have to span necessarily one beam to the next. And it can free up your floor plate in terms of where you want to locate your columns. This is our project for the Ontario Secondary School Teachers Federation, so that's the teachers union. So this is largely office space. And it is only a three-story building. So again, that floor to floor wasn't as crucial. So you can see that there's no air distribution in the ceiling. We have a raised access floor here, giving us a ton of flexibility on the ground. We still have to run our sprinklers above, so we do have that level of coordination. And then you get this lovely effect of the girders and this almost coffered-like ceiling with a very flexible floor plan, partially helped out by that raised access floor. But again, you have that deep beam, and that will add to your floor assembly thickness. Next. And then the other configuration is a point-supported system. This is not our project. This is our colleagues over at Acton Austria in Vancouver, and this is the Brock Commons student residence for UBC. So this was a FASTNEP engineered project that uses a point-supported system. So point-supported is exactly how it sounds. It's essentially eliminating all of the beams in the floor plate and supporting those CLT slabs at the perimeter of each slab. So really taking advantage of that two-way action that you're getting with the CLT. However, those slabs do have to be supported obviously on the edges. And if you are thinking about a CLT slab, that'll kind of max out at about 2,400 to 3 meters wide. You will need a column every 3 meters, and then in the long direction, you can probably go about 4 before needing another one. So while this has huge advantages in terms of efficiency in using your timber, um, there are no beams. You can run your mechanical systems pretty much wherever you want, almost as if it was a concrete building. But the major drawback is that grid density. So if it's a project like this, like a student residence, it makes perfect sense. And other kinds of residential uses, we definitely look to point supported as a system. Um, where you can handle a denser grid. When we're talking about educational spaces where you often need that longer span for classrooms or auditoriums, then this doesn't really fit the bill. However, when we start to combine this with other systems, you can have a point supported elements within your floor plan. And we'll touch on that a little bit later and how we took advantage of a point supported aspects in our kit. Oh, just one more thing. The point supported systems, typically you're going to have a thicker slab just because you don't have those beams. Um, so you're going to go probably at least 5 ply with a point supported project. Whereas if you're going beam to beam, sometimes you can get away as thin as 3. Um, and that's really uh, it adds up quickly over your entire floor plate, as you can imagine. Thanks. And then this last kind of typical strategy would be to actually use CLT as a load-bearing wall. So you'll see this more in residential applications or even single-family homes. Um, we in our educational projects, typically we're looking for a little bit more flexibility in terms of our grids and our layouts. And so using CLT load-bearing walls kind of ubiquitously throughout a floor plan often doesn't make a ton of sense. However, we have used them in different building elements. So this is a campus service building for BCIT that is starting construction right now. And as you can see in that section, we've used the CLT as the elevator and stair cores. So those pieces aren't going anywhere. That's not going to get moved in a renovation, and it can take quite a bit of load. So we can put an elevator core in there and really try to cut out a lot of that embodied carbon that would otherwise go into a concrete core or a steel core. And then the plus side is also you get to see all of that wood. So the CLT walls really do put the wood front and center. Um, but they are difficult to work with in terms, especially if it's a wall that you might need to run services through. Um, it's a lot more of a rigid member. Next. And then the hybrid system. So just taking those different elements and different ways of laying them out and seeing what else you can do with them. So this project is our Limberlost Place project down on the waterfront here in Toronto for George Brown College. It's just finished and students will be in there in the fall. And for this project, rather than using those deep beams to get our spans, we've taken a CLT slab and essentially turned that beam on its side. Um, Using a structural concrete topping on top of this slab with a steel bar connection that actually allows the timber and the concrete to work in concert. We're able to get these huge 9-meter spans that not only make that span, but then carry the load of the CLT slabs that are kind of infilling between those what we call slab bands. So that slab that's running uh, the slab band rather that you're seeing a little bit lower than the rest of the ceiling is a 7-ply with a concrete structural concrete topping, and then the infill slabs are just a 5-ply. So you get that kind of a coffered look with 1200 wide glulam columns to account for that tipping factor. Next. So some of the other factors that we really have to consider, especially when we're talking about a public school or education spaces in general, not to mention residential pieces, are the acoustics. So while there's like a ton of reasons that we love building with wood, acoustics is definitely a disadvantage. It's so much less dense than its concrete counterpart that it tends to transmit sound much easier. So there are different strategies that you can use to mitigate that. Generally, a concrete topping is required on top of your CLT slabs. That helps just give it a little bit of mass. It also helps with the fire rating from the top. But in order to mitigate that impact sound, we'll use an isolation mat between the concrete topping and the wood slab to really decouple those two pieces so that those footfall and other impact noises aren't going to be translated to the units or the classrooms below. A lot of these acoustic pieces are driven by our goal to expose as much of this timber as we can to see if we can get those drywall ceilings out of the projects so that we can see it, and as well just the embodied carbon of that material. So if we're trying to really take care of all these acoustics without adding additional material, it gets a little bit tricky. So the impact is generally solved with a concrete topping and an isolation mat. There are products that are coming on board now that are dry laid systems, generally made of post-consumer gypsum, that can take the place of that concrete. But they're just coming online now in terms of being tested for fire rating. And there's still a couple of bugs that I'm not entirely sold on yet, but it's a great system. It also would allow for this to be for disassembly a lot easier than with the concrete. So the footfall is with that sandwich assembly. The sound absorption that I mentioned earlier, that DLT and those kind of products have a solution for. It doesn't exist with CLT. So CLT, we've got this hard surface along our ceilings that we love to see. So we don't want to cover it up with ACT. So we do have to find that absorption somewhere else in a room, especially when we're talking about classrooms where we've got children or students that need to hear what a teacher is saying. We don't want any of that to get lost in reverberation or noise coming from across the wall or across the hall. So in our project, we did have to find acoustic panels and space for it along the vertical surfaces to be able to keep the ceilings as exposed as possible. And then the real tricky one, and you'll see that this was a real driver in our planning, is the idea of flanking sound transmission. So that's that diagram at the bottom right with the blue arrow, where if you can imagine that partition is between two different classrooms, if we have a CLT slab that spans from one class into the next, that is exposed on both sides, it makes for a very easy path for that sound to travel along and basically act as a speaker on the other side. You can solve that by encapsulating one side, but if code doesn't require you to, and you really want to keep it visible, then you're kind of limited to about a 45 to 49 STC, even if your partition is upwards of 60, because you have that bridge. You're going to hear what's happening on the other side of that wall. The the best solution or the most fail-safe solution that that you can do is to locate your panel joints in the same location as your acoustic partitions. So that dotted red line would be the ideal spot to break your panels and really decouple that sound from going from one classroom to the next. Like I said, there are some solutions that we can do, and sometimes we're in a position where we can't orient our CLT in that orientation, but wherever we possible, that's the goal. Sorry, next. And then code considerations. So I don't want to stay on this for too long, but just so that everybody's under the same understanding of how we designed this project, we actually designed this project per the OBC 2024. And in the 2024 code, before the new amendments that came out in January, A2 occupancies didn't have a consideration in terms of mass timber construction. So you would be looking at an alternative compliance, which we've done for other projects, but with a client like the TDSB, we were really looking to avoid as much risk as possible when it came to the authorities and approvals. And so we fell into, or we decided to go with the 2226 designation, which gets us into the combustible construction. Luckily for us, I think that the TDSB had a really good kind of forethought in terms of this pilot project to pick a school that that was actually quite small, so we could get into that 2,400 square meters for the whole building. It was very tight, and it was no easy task to get down to that piece, but it aligned roughly with the ministry guidelines. And that was a major factor in terms of how we designed the kit. More recently, now as of January, we using the new table that's included in that amendment for encapsulated mass timber, A2 buildings up to 7,200 square meters and 6 stories have that 0-minute encapsulation rating, which is great news. So props to them. And we may end up actually moving into this piece because, as we'll mention later, the project is just now wrapping up working drawings, and so we may end up in the new code. There's a great guide that Woodworks put out that tells you all about the new requirements for 2025. If you haven't picked it up already, it's a wonderful resource. Next. So these are all of the parameters and the reasons that we love it, and then maybe just really why. So the overall arching reason for mass timber is the carbon. This is the image on the top right is from Bureau Hoppold. It's a great clear representation of what happens when you start to switch out concrete and steel pieces with timber. And you can see the embodied carbon just drop down to 40% when you get really aggressive with the timber pieces. On the bottom right there, that's a study that we're doing currently. We're involved with a fairly extensive life cycle analysis of the George Brown project that was just completed, looking at every single construction detail. So often a life cycle analysis might stay fairly high level, but this one will include all of our custom steel connections and rebar and everything else to really understand what actually the final numbers are, and we've used those results to inform this project. Carol is heading up that study, and it's just great information that is affecting our design process in real time. Next. Wood is is obviously a local product for us, especially given our not so friendly issues with our neighbors right now. If we can reduce the amount of steel in the buildings, we will take every opportunity at this point. Just again, that risk mitigation, things get a lot more predictable when they're coming from your neighbors. The image that I'm showing here is from the Natural Resources website. NRCan has this wonderful interactive map that tracks every mass timber project that's happening in the country, as well as all of the suppliers. If you search NRCan Mass Timber Map, you'll find it right away. If you haven't already checked it out, it's a great tool. I've kind of highlighted 4 different suppliers in Canada that stick out because those are the only 4 that are producing CLT right now domestically. So in BC, there's Mercer and Glesnikov, which have Glesnikov has a beautiful product that can get up to 3 meters wide, and in our neck of the woods, there's Element 5 in St. Thomas that can produce a 3 meter wide panel, and then there's Nordique up in Chibougamau, Quebec, that is limited to a 2400 wide CLT panel. But they do all of their own glulam. They supplied the George Brown project as well as the OSSTF project. So in our neighborhood, we really are beholden to kind of 2 different suppliers, unless the folks in BC get really interested in what we're doing. So another reason that we think mass timber makes a ton of sense for school projects is just how fast it is. So when a lot of the public school projects that we've worked on end up as load-bearing concrete block with hollow core slabs, the load-bearing block is just so kind of painfully slow, and takes a lot of labor, and it takes a lot of carbon. And you're left with painted concrete block. We've done those schools. They do the trick. The TDSB knows how to maintain them and how to build them, but they're quite slow. Whereas a mass timber solution, because it is inherently prefabricated, can go up very quickly. So, for example, the George Brown project, we could do about a floor a week, and that's with about 6 to 8 crew members landing those mass timber pieces versus a cast in place project. You look at 30 or 40 people on site with all of the different formwork and rebar and pouring and all the trucks and everything else. So when we're dealing with these residential neighborhoods where schools are often located, the quicker we can get out and the quieter we can get out, and they just smell great. It just makes a lot of sense for the school. The predictability. So this is another one that we love about working with timber, is just when you draw something, it actually ends up exactly where you drew it. Even over a 10-story building, you're accounting for maybe a concrete core to be out 2 inches, but the timber will have a tolerance of 1 to 2 millimeters, and we found that to be the case. It's almost too accurate, where you're just bang on all the time, and any of your kind of tolerances are always happening between the timber and something else, and that is just because it is all CNC'd. We have in this project, which is the OSSTF, these custom, or these weren't custom, these are off the shelf aluminum concealed fasteners that are embedded in those beams that have to be exactly bang on for it to work, and then you don't have the changes when one thing is an inch in the wrong spot. And then the last one, Carol, thanks, is just the biophilic properties. So there's a lot of studies about biophilia and how great it is to just to be surrounded by natural materials. I think this image captures it pretty well with that student just posted up right next to that huge spruce column. It just feels good to be next to natural materials versus maybe that concrete block wall that we talked about earlier from the other school projects. So as the more wood that we can put in these classrooms, that kind of calming effect and that idea of being surrounded by the natural environment, we think makes perfect sense for a school, public schools especially. And then into the kit.
All right, thanks, Will. That was a lot of information, which is great because it's
Sorry.
going to help. It's going to help to explain how we get to where we get to. So thanks for that. So kit of parts, I'll start to talk a bit about this kit of parts concept. So what are we talking about when we say kit of parts? The goal is to increase our efficiency, and efficiency both from our perspective, both in the design process and in the construction process. So there's a lot that's been talked about in terms of accuracy and speed of construction that happens in the construction side. And then the design side can have this similar kind of thinking when we work through it. And the two, as we work through this process, they inform each other. And we found that as we worked through this project, we were sometimes at the same time working through a teeny tiny detail of a connection and then flipping over to the bigger picture of the overall design and constantly moving back and forth between the two of them. So the design kit, so this is where kind of the starting point of this. So, we all get these program areas either from clients or we develop them with clients to figure out what are the spaces they want, how big are these spaces. In the case of TDSB and other school boards, a lot of these spaces come through a formula from the Ministry of Education, and you get this spreadsheet and you have all of these different types of rooms and they all have different sizes. And then we also then kind of look at the other side of this, which is the mass timber grid and the what is optimal for mass timber construction. And from all the knowledge that Will has kind of told you and all those things that we have in the back of our mind, and then trying to merge the two together. The great thing about schools is they're quite prescriptive in their programs. And so a classroom is typically the same size throughout most schools. If you have more kids, you just have more classrooms. They have a lot of spaces that are repeatable. And so it's quite conducive to this kind of kit type thinking. So in the case of the TDSB, we also knew that we'd be working likely with a double-loaded corridor. So that also became the basis of the starting of this. So you see this kind of double-loaded corridor grid that starts to emerge. And we generally start with kind of multiples of 3 meters when we work with mass timber. That seems to be a good starting point. As Will mentioned, there are panels that are being produced at around 3 meters in size. So that becomes our starting point. And then we're looking at this kind of large variety of room sizes in this program. And how do we now fit this into a grid? Because they wouldn't necessarily match exactly what we're trying to achieve. But we start to group things together. We have things like classrooms and staff rooms that are similar size, kind of larger size spaces, resource rooms, maybe change rooms that become medium-sized spaces, and then meeting rooms and storage rooms that then become smaller type spaces. And we try to kind of organize the program into these kinds of groupings. And then ultimately then what happens is we start to kind of slowly adjust things. So slowly adjust the grid for the mass timber and adjust room sizes and try to match things. Like we in our program, for example, we got things like a typical classroom is 72 square meters, but a special ed classroom is 68 square meters. So part of this was a conversation with the client to say, can we make all our classrooms the same size and not have a 4 square meter difference? And so and the same exercise as a lot of other spaces that we were given. And then adjusting the grid then to find that kind of sweet spot that worked with the areas that they were trying to achieve and worked with the optimized mass timber construction. And so you'll see that we then start talking in terms of number of bays rather than square meters for a room size. So for example, classrooms and staff rooms become 3 structural bays. Resource rooms and change rooms become 2 structural bays, meeting rooms and storage rooms become one structural bay. And this helped us to always stay within the grid and helped us then all the way through to detailing in the end if we were quite rigorous with this type of thinking. So then what we have is, as we kind of have this double loaded corridor piece, we're now starting to pull this together, and we're now getting to kind of going to the building scale of the kit. We're now creating these wings of a building, which then, if you continue to apply this kit type thinking, we can adjust these wings to various sizes. You can start to arrange them in different ways. So you can see how this kind of kit piece can start to create all different sizes and shapes of buildings, depending on the requirements from the client and the site and the needs of the project. So back to Will, who's going to then go through this construction kit.
Yeah, thanks, Carol. So as Carol was mentioning, this was kind of our guiding principle, was that grid that we ended up with, in terms of, massaging those different programming areas to be able to fit in this increment of roughly 3 meters, with that about a 2.4 meter corridor, double loaded corridor space. That's kind of ubiquitous throughout our public school projects. That's the ministry standard. That's what's going to get us into that ministry template guidelines. If anybody's had to contend with those on their projects, you know that they're relentless in terms of hitting those areas. And so so this was our real starting point, and then it was from there, how do we achieve this layout in kind of the most efficient way and the most flexible way that we can with the mass timber. So if you go to the next one, the very first thing that we wanted to start with was this notion of a point supported corridor. So as I mentioned earlier, with in describing the point supported system, this was kind of a no-brainer for us to be able to use at least point supported slabs in the corridors, so we don't have any beams that are dropping below that slab that are going to impede air movement, like duct distribution, IT, all of your plumbing and HVAC piping and all of that kind of stuff. We needed to keep those corridors completely clear. So we started with the point supported corridor, and then it was a question of, okay, how do we get from there to that perimeter wall, and what are we going to do to span that gap? So the easiest way to do it would be, or the most straightforward rather, would be this deep beam structure, similar to that image I showed previously at the McMaster project, where you just take a glulam beam and you run it all the way to the edge. So the issue here is that you get a very kind of a dense structural grid where you don't necessarily need those columns every 3 meters on the outside. You might need them for the corridor, not necessarily for the classrooms. And the other kind of more was, I don't want to say serious, but the other issue for us was the next slide, Carol, is that if we're running our beams perpendicular to the corridor, then our CLT slabs are also going to run parallel with the corridor. So this brings up that acoustic issue where we don't have that opportunity to break those panels at every 3 meter grid, because our goal was essentially to have this system and be able to locate our partitions at any one of those hidden lines, at any one of those 3 meter spots, to be able to slot in a resource room or a bathroom or a classroom or whatever. And if we don't have that flexibility acoustically, then it really poses a problem where you get into tricky details of encapsulating some rooms and not. So our goal was, okay, how do we then take this system and be able to orient that those classroom slabs perpendicular to that corridor? So if you flip to the next one way of being able of giving a little bit more freedom with our slabs is if we start to introduce a girder, and then we can move those, split those those beams into two and move them a little bit closer so that, again, we can take advantage of the fact that your CLT can actually span in its width. And then we get the panel layout that we want, but unfortunately, if you go to the next slide, if you remember, the those beams that are supporting those girders are now running parallel to our corridors, essentially impeding any mechanical services that might want to dive into those classrooms at any point. And so from here, the question was, okay, how do we get rid of that beam that's really going to cause us all kinds of issues? We don't want to be CNCing out duct openings and conduits and everything every time we want to put in a different room. And if they want to renovate later, that's just not going to happen. So the next slide is really where we landed. And so we actually switched out our glulam columns for CLT columns, which we kind of dub wallums, which is a term that we use quite a bit around here. And what that did was it kind of spread the ability to carry the load of those two beams enough that we can still land our CLT perpendicular to the corridors, and then it opens up that gap between that double beam configuration to be able to feed any kind of services that we might need at any point along that corridor, and it gives us that acoustic isolation gap at every 3 meters. If you go to the next slide, Carol, you can see that we still maintain that piece. And by using CLT instead of glulam, we are kind of keeping all of that product kind of coming from the same source. CLT is generally a lot cheaper than glulam. It's a little bit more of an industrial kind of a material, and you'll get that with the finish on it. It's not kind of millwork quality. But you also get the cost savings. The other thing that it does is that our wallums here are 915 wide with a 235 gap in between them. And so essentially 1/3 of your exterior backup wall is already there in terms of your structure. So you're essentially infilling those just over 2-meter voids with either windows or wall assembly, solid wall assembly. And then the same thing can happen on the corridor side, where that gap is just wide enough to fit an accessible double door assembly. So on the corridor side, we've got a single door with a side light, or a double door, or an opening into a washroom. But we really kind of, that dimension took a lot of tuning to make sure that we could fit all the different components that might come up in specifically in an elementary school. Next, so here's essentially the pieces and how they stack up. The CLT wallums are 5-ply. And then they pick up both that ceiling classroom slab as well as the point supported corridor slab. And what you'll see here is in that kind of exploded axo on the right side, that we have the opportunity, because those glulam beams did reduce in size, to actually pre-laminate those pieces together. So the glulam, the 2 glulam beams and that CLT slab would be prefabricated in the shop and come on the truck already assembled, which essentially cuts our crane picks by 2/3 in terms of dropping these pieces on site. Which was again a huge deal for us, was to really get the speed. They would be stacked just on top of each other, but so we are shipping a little bit of air there. However, the weight that a truck could take generally meant that we wouldn't be able to get more than about, I think it was, Carol, was it 6?
Five even.
stacked up. And then the idea there, we toyed with ways of nesting them, but having to flip a panel is much more pain than any kind of space savings that you would get from nesting them. But the prefabricated cassettes are a huge deal and just speed up the process so much. The other thing that you're going to see in this diagram is that on the corridor side wallums, there is a notch in the middle of that wallum. And if you flip to the next slide, I think I've got a close up. So because that wallum is so wide and the load is spread so much, that middle portion isn't actually structurally required. And so so we worked with our engineers. Sorry, I haven't mentioned it yet, but we worked with Aspect structural engineers on this project, and they've been awesome. We worked with their Toronto office as well as one of the principals out in Vancouver, and they really know their stuff in terms of mass timber. But they kind of let us know, like, there is this gap that we can take out. We're already CNCing this pocket for those beams to sit in. So that wallum is going to be sitting on a CNC machine for a certain amount of time anyway. And we can introduce this void. And for us, that puts it right in between that double beam configuration every 3 meters. So every 3 meters, you have an opportunity to drive services right through the wallum, whether it's your HVAC. We've got a VAV box that actually slots right in between those beams within the classrooms. Sprinkler lines, electrical conduit for speakers and all of that kind of stuff to keep that middle section completely exposed. So this really gives a ton of flexibility in terms of our layouts. We always know where there's going to be openings and where we can dive in from the corridors. Next. So then this is what happens on the exterior side. So we don't have that opening, and then those pieces just slot in. We also are looking at wood to wood connections here. So those screws would kind of come right through the face of that wallum into those beams, and so there are no custom steel connections, and we're just looking at really dropping the carbon in that case. And then this is what it looks like in a class. So you can see those double beam pieces. We filled them with an acoustic panel on the bottom, and then inside there is where you could run your sprinklers and your HVAC distribution. Leaving those ceilings open, and they're also the right thickness to allow for a millwork piece and a partition. So you can see on the left side of that image, the cabinets just fit right flush with them, and you can run your plumbing up into those cavities. And then if you need a slightly larger space, this is a library where we've actually subsumed the corridor piece, because this is at the end of a corridor, to introduce these kind of reading nooks that Carol will get into a little bit later if I don't use all of her time. Next. And then when we get to the bigger pieces, obviously we need longer spans and higher heights. And this is essentially, it's a little bit more of a custom piece, but it's basically a supersized version of the same kit. So we're on the same 3 meter grid with the same width wallums, but now they go up to a 7-ply. And then rather than the glue lambs, we've got about 1 meter deep CLT beams that have this waffle configuration to help with some of that twisting. Just right in line with the kit, and they just kind of slot right next to it.
Okay, all right, thanks, Will. So I'll just dive into then, after everything you heard and how we did this kit and all the work we did to make it work, what the final solution was. So this is about using the kit. What do we do with all those pieces? And how do we then come up with a final design solution? So ultimately, in this case, and likely in a lot of cases, your site and the client requirements then begin to shape the final design solution. So when you have so many options that you can do with a kit, you need some constraints, and you draw on them to be able to come up with a solution. So just a quick overview of where the project is. So this is a school. It's in Scarborough here in Toronto. So for those of you who know Toronto, it's south of Kingston Road between Markham and Morningside Avenue. The site, if we're zooming into the site now, it's mostly in a residential neighborhood. It's a fairly easy site. It's quite flat. And there's a small commercial plaza on one side, and then we have a beautiful park and community playground at the back. The influences on the site then became a big part of how we pulled the design together. So one of the biggest things we had to deal with, and this goes to what Will was saying about, you know, building in a residential neighborhood, not only did we have private residences to deal with, but the existing school on the south side of the property was to remain operational during construction. This became a huge conversation that we had with them. And a big consideration for the final design. The other piece, and this is a client requirement, was there's this requirement for keeping play areas consolidated as much as possible. There's a huge issue with supervision in these schools, and so they want to have visibility of kids playing, keep them safe. And so to have play areas consolidated into one larger zone was the best solution for them. And then on our end, when we're dealing with sustainable buildings, we're always keeping in mind our solar orientation. So in this case, the site is generally facing north-south, it's oriented north-south. And so we're just keeping in mind the building orientation to minimize our heat gain and maximize daylighting. So this was another piece that came into play for us. So the final building location actually ended up at the very north end of the property. A bit counterintuitive, but this is coming from those requirements where we had to keep that existing building working until the new building is complete, and trying to consolidate play areas rather than have too many, you know, courtyards or L shapes that would then create these kind of nooks that were harder to supervise. So this also worked out fairly well in the orientation. So you'll see we end up with a fairly linear building, oriented almost east-west, which helps us minimize that heat gain and maximize our daylighting. So just a throwback to where we talked about the kind of overall kit at the beginning, you can see that this was generally these kind of two wings in a linear orientation with a bit of a shift. You can see that's what our ultimate solution was for this project. And on the right, you see all the little blocks. I'll get into those in the next slides, but all the different blocks and all the different program elements within the mass timber grid. So this is an overview of the site plan. So you can see the existing building on the south, the new building to the north. And so once the existing building is then demolished, you're going to get all of those play areas in one large zone consolidated at the front of the school. We have the main entrance that sits at the center of the building facing the street, even though it's far away from the street, it's facing the street. And then we have a childcare in this project as well. So that was another challenge that we had to work with. And we created a separate entrance for them on the west end of the building. And just a quick overview on the solution for the site. So the pickup and drop off is always a big consideration for schools. So we worked with a one-way loop that draws everyone right into the site and connects it to drop off areas for the school and a separate drop off area for the childcare. Try to minimize the traffic on the road. And then combining that then with the strategy for keeping the play areas separate from the vehicular traffic and the general public. So, and creating lots of pedestrian access to hopefully encourage walking. So some main pedestrian access points and then secondary ones within the site. And then just a quick overview on the play areas and how it worked out. So you can see on the south side of the building, all the highlighted areas, those are all the main school play areas, the playgrounds, the hard surface play areas, kindergarten playgrounds, and the main play fields. And the north side of the site was then reserved for a private learning garden on the northeast corner. And then the childcare play areas had an opportunity for them to be completely separate from the rest of the school, which worked out quite nicely in the end. So to the floor plan, I won't go through every single room in detail, but it'd just be interesting to show that, all of this kit of parts talk, but the overall floor plan translates itself into what is seen as a pretty traditional architectural floor plan. But just to show you a reminder back to our kit of parts grid, you can still see that it's really comprised of this very regular grid that can march itself along, and then the spaces then work themselves within that grid. And if we go to our little program blocks again, you can see how those are still there in the overall solution. So we have sort of the 3 bay spaces, classrooms, staff rooms, etc. The 2 bay spaces that then work themselves in there. And then the 1 bay smaller rooms that are mostly meeting rooms, storage rooms, smaller spaces like that. And then level 2 is a similar thing, mostly classrooms up here, which was easier. 2 bay spaces, and then single bay spaces. And I'll just say this, that, Will talked a lot about this decoupling and the ability to have something at every 3 meters. We have a joint at every 3 meters. We have the ability to pull services in at every 3 meters. We went through a lot of versions of this, and every time there was a new requirement, it really worked like a little slide puzzle, because everything was so modular, it was in blocks, it was quite easy to switch rooms around, knowing quite confidently that it was still working within the kit. So it was really interesting that it got tested various times, and worked out quite well. And it's still working out quite well for all of the services, all the mechanical conversations we're having with the consultants, and to build that right into the whole project. And then just a little word on some of these other spaces. Will already mentioned the library. So, this is not just about 3 bay and 2 bay spaces. That's a conversation because those are typically the sizes of spaces that the TDSB and schools would require. But obviously larger spaces can work themselves into this kit as well. This is the library. So the library became a 5 bay space. And then, as Will said, it absorbed that corridor grid into its space and created a nice little nook. And then the gym that Will already talked about, just interesting to show you how it still sits at the 3 meter grid marching along. But what we're dealing with is the columns become slightly bigger, the beams then become deeper so that they can span longer. And then it can just easily attach itself then to the outside of the building, and continue this kind of 3 meter grid that goes along the whole project. And then finally, just a kind of the heart of the school in many ways, is this courtyard. In talking about all of these kits, we keep thinking about blocks and we're kind of adding and creating massing, but a reminder that, the same way you create massing, you can actually subtract from the kit as well. So you start to subtract from certain zones. At one point, we were thinking about courtyards on the upper level. It's just a matter of subtracting some panels and spaces, and you can start to create voids and carve into this kit. So in this case, the solution was a courtyard right in the center of the building that connects nicely to the front entrance on the south, and the library to the north. So we're looking forward to seeing that build. And then I just wanted to touch too on, the intention of the kit is not that we're going to end up with buildings that all look exactly the same, that these are just all going to be copy paste. It's really meant to be a framework to speed up the design process. But working into each project, its own unique identity. And that's become a very important piece for us. So in the case of Poplar Road project, we looked a lot at the cladding and how we're going to clad this building, moving away from decarbonizing again, away from some brick elements. And we looked at the surrounding landscape. So the Scarborough Bluffs being nearby was a big inspiration, and the layers that we see in the soil that happen at the bluffs. And then a bit of the history of the place, a kind of farming history and that kind of cladding, that wood clapboard vernacular, and then reinterpreting it a little bit in a modern way on the building. We ended up with this nice vertical shiplap cladding. So it's just reminiscent of those two elements and brings that kind of unique character to this specific project. And then also giving an allowance for kind of creative moments to happen, right? To just kind of bounce off of this kit concept that we have. So again, for this project, we've introduced canopies in certain areas and then introduce this one kind of curve for each canopy that then starts to contrast to the rest of the building form. So we're trying to encourage, customization for future projects. We just want to keep creating customization and giving a real sense of place to each one of these projects, despite this whole kit background that it may have. And so just ending on a view for this section, at least, I think there's a little bit more that we'll get into, but just kind of where we started at the beginning slide. But now that you've seen the context of the project, this is a view looking towards the front entrance across the playground. So from the south, looking towards the north of the building, where you can see how it's all pulling together, this nice linear form. It's a bit like kind of building in a park type feeling is what we should end up with. And I think it works quite well. And yeah. And then just a little bit, I'll pass it back to Will, a little bit on the mass timber procurement strategies, which becomes a pretty important element when we're working with these projects.
Sure. Thanks, Carol. We've only got 2 left, so hopefully I
Yeah.
can get through these pretty
Should be
quick.
okay.
So I think a lot of our projects right now, working largely in post-secondary space and other public buildings, we're seeing the shift over to CCDC 5B and a CM process, and are finding that that is super valuable when it comes to timber, to be able to have those direct conversations with the suppliers and with the installers, and with your GC themselves. Ideally, even to procure that timber early. With Limberlost Place, we had to secure a whole section of forest about 2 years before it went up. But in applying that same thinking and coming into a project with the TDSB, who and other institutions are the same way, that have a standard of using a stip sum delivery method. How do we kind of mitigate for that, and how do we plan for it? So the little graphic on the left just kind of shows you, if we were to go through the CCDC2 in a fairly straightforward way, we would finish our CDs all on our own, tender the project, and then that timber would be awarded to one of those suppliers that I mentioned earlier. And at that point, we would then have to adjust the design to meet the specifics of that mill or that factory, which can be quite onerous. Right now, mass timber isn't like steel. If you have a W section that's a certain size, it's not going to be the same thing, or a W section is going to be the same thing coming from Hamilton or coming from wherever. Whereas a CLT panel is not. Certain places can make them at certain sizes, and other places cannot. And so if you want that open competition in a project like this, you have to have that worked into your design process. And so for us, what we did right at the outset was that we actually had Element 5 as a team member, just in a design assist capacity, so that we could bounce things off of them at the beginning, still definitely leaving that scope open to other bidders once we actually tendered. But at the same time, worked with the TDSB to actually transition to get this project delivered under 5B. And so we are very excited that they have taken that step, and that we have moved into a 5B method, even though we are quite far through our working drawings. Even just that little bit of having the opportunity to have that direct discourse with who's installing, and potentially where it's coming from. If you go to the next slide, Carol, what you can see is that this is a sheet right out of our working drawings, showing that same classroom floor assembly cassette, built up 3 different ways to accommodate different suppliers. So the top one has that 3 meters wide slab that element 5 could produce, pre-assembled with our double beam, and that could come straight off the truck. The bottom one is showing a 2.4 meter slab, pre-assembled to the double beam, but with a kind of an infill spline. And this would allow for Nordique to produce this slab in their facility. And then the middle one actually shows how you could prefab the middle piece, the smaller piece, so that you could get all of these elements in a C-can if for whatever reason they wanted to open up the tender to come from Europe and get some pricing from Austria or other places, which can surprisingly come in cheaper than our Canadian supply. Obviously, we'd love to see it stay in Canada, but even just the procurement method of this comes right down to affecting our detailing and how we develop the project, and to be able to have these kind of options in our back pocket throughout the process, so that we know that whoever gets it, we can still deliver this project, and the next school, if it goes to somebody else, even if it's not this one. And I think we're 10 minutes over, so hopefully that we didn't lose too many of you. But thank you so much for sticking with us.
Yeah, we still got everyone on the call seems to be sticking around. So really great content, and
A good sign.
we've got a few questions already in the hopper. And I'll just take a moment to remind everybody on the call, now is your time. We've got 20 minutes for Q&A. So please, when you see that button at the bottom, the Q&A button, that's where you type in your question for Will and Carol. First question from Gabriel is, with CLT walls and slabs, what fire rating can we get? Very specific question.
Sure. Do you want me to start with that one, Carol?
Yeah, go ahead, Will.
Great. So with mass timber in general, what you design structurally isn't necessarily, or the size of your member isn't necessarily what you need to structurally hold up the building. So if you have a 400 by 400 glulam column, you might only actually need a 350 by 350 column, and that extra inch is essentially what we call a char layer, and that will get you an additional hour of fire rating. So as the idea is, as your column starts to char, you're still structurally stable, and depending on how much extra time you need, you oversize your wood structure to accommodate for that. With this project, because we fit in that 32226 with the combustible construction, we actually only required a 3/4 hour separation for our floor assemblies, and so we could get that fairly easily. And obviously the concrete topping at the top side would give you that encapsulation. But if you're looking at a CLT wall, sometimes you need your engineer to actually tell you how much they needed of that wall, and then potentially encapsulate one side. So for our corridors, we actually have drywall on the inside face of that, and that's mostly just to be able to run our services, like electrical conduit, past those wallums and not have to go through them. And it gives us an additional acoustic rating, because your CLT might only get you like an STC 40, but by furring that out and having that extra single layer of drywall on the inside, we can get up to the 55s and 60s that we need. Hopefully that's answers your
Yeah, I was
question.
going to add too, Will, on the corridor columns. So wherever we have columns encapsulated on one size, the column size could be smaller than locations in that library zone where the library absorbed the corridor, and those columns are now exposed on all sides. The columns were then upsized slightly. The same with the corridor, since we're having a ceiling in there anyway, we encapsulated the underside of it behind the ceiling where you don't see it, which allowed us to then have a thinner slab. So, we kind of balance the structural size members with that requirement for char and encapsulation.
Okay, thank you. The next question from an anonymous attendee. What do you do about rain and snowfall exposure to the wood during outdoor storage of the parts and during the obviously outdoor construction process?
Yeah. So moisture is yeah, it's like your number one enemy with mass timber projects. I will say that typically how we get the timber members is kind of a just-in-time model where they don't sit around on site before going up, so off the truck and onto the building. Um, but even when you're on the building, it's not enclosed, and so uh, every project has a very specific moisture mitigation plan in terms of how you're going to keep water from dripping all the way through your building. Obviously, the kind of the race is to get the roof on as quickly as you can to stop any of that water from infiltrating down into it. With this project, we've only got 2 stories, so hopefully that'll happen fairly quickly. And there are things that we've learned from other projects. Limberlost Place being one where there is a detail between your CLT slabs where to connect them structurally, we had a plywood spline is what they call. So you would router out about a half-inch groove on each panel, and then you would screw down a piece of plywood, and that would give you your diaphragm between the 2 panels. However, the issue was that if it would rain, that plywood it would essentially just soak up all of the rainwater. And even if your CLT is going to dry out at a fairly decent rate, those plywood splines would just stay wet, and you have to hit a certain moisture content in your wood before you're allowed to pour that concrete topping. And so we ended up having to rip splines out and replace them just because they weren't drying out. And so now our typical detail has a product from Simpson that is a like a sheet metal product that you can screw in along your CLT slabs. You don't need to have that time on the CNC machine to get out your grooves, and you're not going to absorb any of that water. And then we'll likely put a membrane, whether it's a Sika wet guard or there's a product called Vapor Shield that will stick onto your slabs during the construction process, but also allow that moisture to breathe out. So it's almost kind of like a Gore-Tex where it's one of those membranes. And then
Yeah, I
there's
was
just a
just gonna,
cleaning process. Sorry, go ahead, Carol.
no, I was just going to add that, I mean, one of the concepts that people forget is the wood can get wet, but the important thing is it needs to dry out. It's when it stays wet. So that spline issue where water is sitting there, you don't even know it's there. Those are kind of the moments that you really want to avoid. But it can handle getting snowed on. It can handle getting wet. You just want to make sure it can also dry out. So that's one of the concepts that we keep in mind.
And any of your steel connections have a specialized coating on them so they won't corrode during the construction process, because that's what's going to lead you to that staining that might happen through the floors that you have to spend forever cleaning up. So if you coat your connections, and obviously with this project, we're hoping not to have any of those custom steel connections. So we're super excited about that, but that's something that you definitely have to watch out for.
Okay. Next question from Ahmed. What would be the total cost per square foot or square meter difference for the construction materials for the same spool between a concrete or steel building versus the mass timber building?
That's a good question. I don't know if we have an answer for that because we haven't done a comparison. I think we did do a cost comparison for another project, didn't we, Will? But it was steel versus mass timber, and we're actually finding that mass timber. We're finding right now the trend is that the cost of construction is generally going up. It's escalating, but mass timber is not escalating as quickly. So we are starting to see that cost differential is coming down. We're hoping that it starts to get cheaper even, but it's fairly new. But that's the trend. I don't have an answer for exactly what that number is, but that is the trend. And let's hope it stays that way.
I think a lot of, if there's cost increases in the material, the idea is that the savings would come in the schedule.
Yeah.
And that's a bit of a kind of a moving target at this point where a lot of the GCs are, cutting their teeth on these projects and figuring out how to do it. Um, Luckily for us, our CM that we have now has a lot of mass timber experience, and we're extremely excited to get somebody like that on the job. And I think that there's a little bit less troubleshooting when people are kind of in the groove now and they understand what's coming and what to expect. And so we'll start to really see some of those schedule savings show up in the final cost.
And even possibly reduction in that risk factor number, right? I mean, when
Yep.
there's R&D involved and there's risk involved because it's a new process, the pricing from the contractors may come in higher than expected as they get, like Will was saying, the contractor, the CM we have on board, they've done this a few times now. Hopefully they understand the risks and they can be more competitive.
Right. Is the wood that you're getting mostly from Canada? It's all Canadian or local?
The mass timber work, yeah.
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 I wonder if that's also a factor now, the world of tariffs that
Oh, yeah, for sure.
local. And I
Yeah.
think that pricing question is just a bit of a gong show right now for all the materials that are coming elsewhere. So
Yeah.
anything
When
I
we
can
were
predict.
when we were doing Limberlost back, that competition we won in 2018. And then there was all of the crazy tariffs that were coming in steels in the first round.
Mm,
I was working on another steel project at Sheridan College, and I'm sure everybody on this call experienced the same thing if you're working at that time, where all of a sudden people would just be asking, like, hey, I found this random piece of steel. Could this work? Because we can't
mm,
get anything. Or
yeah,
meanwhile, the timber project, the costing didn't even change. It just kind of like
mm,
kept on going. Because like I mentioned, we had that forest squared off since
right.
day one, and because Nordique is completely vertically integrated, so they own their own forest, their mill, their production, and they can even install it for you. That
Wow.
predictability is all it's all there, and so
Mm.
that means a lot, especially to these public clients.
I
I
could
was gonna
imagine. Yeah, that
Yeah.
stability being so key. Very comparable.
Yeah, I was going to add that we did actually do an escalation check at the beginning of the project from a feasibility number that was there. So it wouldn't have been the span of about a year difference. And yeah, there was definitely an escalation, but the mass timber number didn't change actually. So that was quite interesting to see.
Nice.
That's the hope.
Yeah, good. Well, it's a good selling feature. So I'm just seeing we have 3 more questions, 8 more minutes, so we'll try to get through them. How does the kit that was established future plan for expansion of the school? That's an interesting question.
Oh, that's a good question, actually, and beyond, right? And even beyond schools. So, yeah, I mean, we looked at some expansion plans. We looked at how this gets added on. The idea, we did not design it to be expanded taller necessarily. We could have had that been something that the school had thought they might expand vertically. So it could have been adjusted for that. So it would be definitely expanding within the site. But yeah, I mean, we see these as you could add another wing. If you think of the little diagram that we had about these wings, right? You're just adding another wing. The kit lends itself better to not necessarily turning on an L, but easily, you can imagine a breezeway potentially connecting to the existing building and a new wing being added in. So I mean, ultimately, you could then also go to volumetric modular, right? Like, can these start to now move towards volumetric, and you're literally building these units, almost permanent portables off-site, and creating them in. So huge potential for this. And little sneak peek, we started to kind of look at this for other building typologies now as well, and how can it work for things like residential. So there's definitely, it is a prototype, and so the kit will likely be tweaked as we go, but definitely huge potential for that kind of thinking. It's the kind of thinking we'd like to have, actually. So how do we expand easily and build easily?
Perfect. And then 2 more questions. The second last, the penultimate question from Francesco. Could you potentially have zero encapsulation?
Uh, You
That's amazing.
potentially, yes.
Yeah, for this
Um,
building, yeah.
for this building,
Yeah.
especially because we're in that combustible construction category. But even in the new code, there is an allowance for that. If you look at the table, there's kind of different ratings. There's a 0 minute encapsulation, 50, and then 70, depending on how big your building is, at an A2 occupancy. So for us, it would be the 0. Um, and you could get away with 0 encapsulation. However, where you have concealed spaces, you do have to protect it. So, um, like Carol mentioned earlier in our project, we have ceilings in our corridors. So once you have that ceiling space concealed, then you do have to encapsulate the underside of that CLT slab. So, or even within a wall assembly, if there is a concealed open space, then you have to encapsulate it. There's products that we've looked at that are almost like an intumescent stain or
Mhm.
paint that you can use on those. That they might require a bit of an alternative compliance or an engineering judgment to get that through. Um, the cost is there where it might be a little bit more straightforward to just go with and they change the look of it to go with a gypsum, but in theory you could have 0 encapsulation if you had no concealed spaces and your building wasn't over the certain space requirements in the code.
Yeah, I was just going to add too that on that kind of slide that Will had on the codes are changing very quickly on this, on the mass timber. And so we're constantly keeping an eye on it. They constantly helping us out in some ways, but yeah, generally we're getting better and better and we can do bigger and taller buildings with mass timber. So that's great. So keep an eye on the changing codes.
Quick shout out to Vortex, who is our code consultant on this project. And if you're looking for somebody that really knows their way around the code and mass timber specifically, then those guys are awesome.
Okay, so the last question, which is actually a nice philosophical question and a one to end our talk today. It's from Sina, and she's a student researcher from George Brown College. And her question is, as an architect, how do you find the balance between creative freedom and the constraints of working within standardized design kits? Does the kit of parts approach empower you or limit your ability to express architectural intent? Really great question, Tina. I'm curious.
Yeah, I could speak to that a bit because I understand where the question comes from because it does look, like it's kind of boxy. In some ways, it kind of, especially for a school, because they've become very prescriptive. And so you need all these spaces. There's certain ways these spaces really work well together. For TDSB, the double loaded corridor was, it's their model. That's how they work. Other schools may do it differently. So in some ways, it takes away all that thinking of how are we going to arrange our spaces and makes that really easy. Like I said, we were literally able to slide spaces around if the client came back with one version and said, you know what, we really need this classroom to be here. We could very quickly slide things around. So we weren't spending so much time fiddling with layouts as much. And in this case, because it's the first one, it allowed us to spend a lot of time working out the kit and the little details and really get into the nitty gritty of it. And I do think, I mean, you start to play with it, it becomes a thing you can play with and you start adding and subtracting. I think there's a lot of flexibility in what you can do. And we continue to explore what we can do with that kit and how the kit can maybe morph for other building typologies. And so, yeah, we definitely, and then the piece about the cladding, right, and adding the canopies and things is where you then start to have these nice elements and challenge yourself in a way. Like, how can you now take this kind of very regular mass timber grid and challenge yourself to do something that's enticing and creative and yeah. I hope that answers it to a point.
Yeah,
Will, do you have anything else to add to that?
Yeah, I know we don't have
Philosophical.
a lot of time, but I just wanted to say real quick that mass timber is something that's fairly recent even for us. We basically just started 6 years ago with the Limberlost project, and the switch to this structural system that all of a sudden, you can't just do anything when you have a concrete, or you add a little bit more reinforcement here or there, and you can achieve a lot of the forms that you can dream up with the right structural engineers. But with mass timber, it really adds this extra layer of rigor that you have to have. And I find that I really enjoy it. I find that we work much closer with our structural engineers on these projects. They're much more integral to the project. You understand exactly how all of these pieces are fitting together, what they're doing. We didn't talking about crane picks in SD wasn't a thing that we would be doing in a typical elementary school project, and to have that kind of help inform what your classroom looks like, I think it's great. I think it's fantastic to have a much more integrated conversations with where your materials are coming from, and and who's putting them together and how. Um, that's mass timber in general, but with the kit, I think that kind of just informs it, is that, there are all these extra limitations. The kit is another one. But that's, I think, where the job gets really fun, is that how do you actually still create beautiful spaces and inspiring places to learn with all of these extra parameters. And if you can pull it off, that's our job, I guess.
Mm, Thank you so much. Yeah, I think about the idea of freedom within discipline.
Exactly, yeah.
That
Yeah.
idea, the more constraints can yield some of the best results. And like you said, paying attention to the materials and having that detail of thought will yield something truly beautiful and lasting. And I think
Yeah.
when I see the photographs and I see some of these projects, that's the feeling that I feel as a non-architect. So great questions, great engagements, wonderful presentation. We'll definitely want to hear how the project unfolds, and invite you back if you're so inclined to share the
Sure.
For sure.
details along the way as the project unfolds. I think that would be really interesting to hear for the
Yeah,
profession.
sure.
And as this thing becomes more, these mass timber projects become more and more common, I think it's such a great topic that, the professions keen to hear about. Just a quick announcement before we sign off today. Next week, we do have a webinar on Thursday, Elevators, Accessibility and Green Initiatives. I think that one is also a climate action webinar. We also have a summer promotion for those of you who are on the call still. Take advantage of that, because it's not going to last. It's going to end next Friday. So do sign up for that. It is the second year of your Con Ed, so make sure you get those hours in. As I mentioned, we will upload your hours for those on the call today. It takes about a week or so do have patience, provided that you did attend 80% of today's webinar. We will also be sending an email with the file, I believe, the PDF, and we also ask for your feedback as always. So please do take a minute and let us know your thoughts on today's webinar and any other topics that you want to hear about. And that is it. Thank you so much, Will and Carol. We would love to hear you, to have you back. And thank you so much for your participation, everyone, today. And everyone have a great rest of
Yeah,
your day.
thanks for having us.
Thanks so
Thanks for
much.
coming.
Thanks,
Thank you.
everybody. Bye-bye.
Bye.